Good morning students, 12th standard physics lesson 3 magnetism. So in this class we are going to discuss about cyclotron. So cyclotron is used to accelerate the charged particles to high kinetic energy. So that is, it's also called high energy accelerator. So the cyclotron is mainly used to accelerate the charged particles. So particularly that is proton, but electron is come under charged particle, but electron cannot be accelerated using cyclotron. Then so what is the working principle behind the cyclotron? So a charged particle moves perpendicular to the magnetic field, it experiences a magnetic Lorentz force. So already know a charged particle moving in a magnetic field. So the magnetic field should be perpendicular. So then the charged particle experiences a magnetic Lorentz force. So the charged particle moving in this direction, so the magnetic field, so both are perpendicular to each other, means then the direction of that magnetic Lorentz force in upward if it is positive, if it is downward if it is negative. So consider, so what is the construction? So there is a two Ds, they are semicircular hollow Ds. So it's a metal container, so it's fully evacuator. So at the center between the two Ds there is a gap. So between the two gaps, between the two Ds there is a gap. So there is a source S. So source S is used to eject the what we are going to accelerate the particle. So the source is used to give a charged particle. So after that there is the D's D1 and D2 are connected with the high frequency accelerator. So high frequency alternating potential difference or high frequency accelerating voltage. Then finally a deflector plate. So this is used to taken out the charged particle with the high speed proton beam. So actually we are using a proton here. So construction, then so there is a electric field and magnetic field. So we are using a, that is D1 and D2 are alternating potential difference. Then this is a plane of 2 Ds. So one D half the two semicircular Ds. There is a magnetic field perpendicular. So perpendicular to that alternating potential difference, they are using a magnetic field also. Then so how it works? So we are introducing a positive charge at the source using the source S. So it is ejected from the source. Now just see this. So D1 and D2. So D1 is in positive, means D2 should be in negative. So alternate. So D1 is positive, D2 is negative. Now, so the charged particle is, what is the charge? Plus. So what happened if so we need to move the charge. So if a charge moves in a magnetic field, it experiences a magnetic Lorentz force. This is a working principle. First we need to move the charge. How? So there is a negative potential is there. So through D2. So positive charge is attracted by the negative. So it moves in a circular path. Why? There is a Lorentz force, it's in circular, that is centripetal force, it acts as a Lorentz force here. So it makes a circular path, it finishes. So again it starts, so D2 is negative, so positive charge is introduced, so it is attracted towards D2. So after that it completing D2 half cycle, then again D1 becomes negative, D2 becomes positive. Then now the positive charge comes here. Then now D1 is negative. So again negative charge is attracted by positive charge. Again here the positive charge, the positive plate is repulsed. So it pushes the proton go into the D1 Ds. So again it goes like that. It makes a spiral circular path. It's not a circular path, it's a spiral. So again the process continues again and again. It come out. So throwing the deflector plate. So using deflector plate they had taken out the charged particle with high velocity or high speed, that is proton beam is taken out. So that proton is used to hit the target. So it is a working principle. So the fast moving proton is used in the nuclear disintegration reactions. Then so there is a centripetal force acts on the charged particle because magnetic field is normal to the plane. So this is a plane. So magnetic field is normal to the plane. So this is the direction of velocity, that is charged particle. This is the direction of magnetic field. So you will get the force acts, that is magnetic Lorentz force acts upward or downward depending upon the charge. Here positive charge. So there is a circular path. So a force acting towards the center. So you need to have some basic idea about centripetal force, then Lorentz force. So centripetal force, then Lorentz force is balanced. So this is due to that magnetic field. So centripetal force is mv squared by r, then Lorentz force, the angle between the charge, that is velocity of the charge and magnetic field are perpendicular. So f equal to bqv sin theta, theta equal to 90 degrees. So sin 90 equal to 1. So directly you will get bqv. Then, so we need to find what is the radius of the circular path. So mv squared by r bqv. So we cancel here. So r is equal to m by bq times v. So from this, what will we infer from the equation? R is directly proportional to velocity. So velocity of the particle keep on increases, radius also keep on increases. So R is directly proportional to the velocity of the particle. Then, so there is a specific condition is there to work, that is resonance condition. So the frequency at which the particle circulates in the magnetic field. So at what frequency the particle circulates, that should be equal to the frequency of the, that is alternating potential difference, oscillating frequency. So that is a resonance condition. So f frequency, that is oscillating frequency, is equal to q by 2 pi m, then frequency equal to 1 by t. So just reverse 2 pi m by up is the time period of the charged particle. Then what is the kinetic energy? So kinetic energy is energy possessed by the particle by which of its motion. If it is moves, it has some velocity, then it should have some mass. So kinetic energy equal to half mv squared. So mass, that is mass of the proton, then velocity, so that velocity of the charged particle. So v, so we are getting v using this formula. So r is equal to mv by qb. Just rearrange, you will get v is equal to qbr by m. So v squared equal to q squared b squared by r squared by m squared. Just substitute, then m squared m cancel. So finally you will get kinetic energy of the charged particle, that is q squared b squared r squared by 2m. Then what are the limitations? They may ask in 2 marks, what are the limitations of cyclotron, or what is the working principle of cyclotron? So the speed of the ion, that is charged particle, is limited. Then electron cannot be accelerated. So what is the reason? So what is the mass of electron is somewhat very less. So the electron cannot be accelerated. Then chargeless particle cannot be accelerated. So it should have some charge. Then only we deflect using the d1 and d2. So neutron cannot be accelerated using this cyclotron. So what you have seen up to now? So cyclotron, what is the working principle? So a charged particle moving in a magnetic field, it experiences a magnetic Lorentz force. That magnetic Lorentz force make the charged particle in a circular path with very high speed. So using that high frequency alternating potential difference, then construction, then working. So basically working is that d is d1 and d2. So if it is d1 is positive, d2 should be negative. Then the polarities of d1 and d2 is alternately changes to make the charged particle moving in a circular path. So charged particle moving in a magnetic field, it experiences a magnetic Lorentz force. That magnetic Lorentz force acts here is centripetal force, a force acting towards the center. So the charged particle moving in a circular path. So that is mv squared by r, that is equal to magnetic Lorentz force bqv. So already I told f is equal to bqv sin theta. So the angle between b and b is 90 degrees. So sin 91. Then we will get the radius. Then radius is directly proportional to velocity of the charged particle. Then some specific condition, that is the important condition, is resonance condition. So the charged particle moving in a uniform magnetic field, say that is should be equal to the frequency of the oscillator, that is alternating high frequency accelerating voltage. Then we find the frequency and time period, finally the kinetic energy. Then 3 limitations. The speed is limited. Then the charged particle electron cannot be accelerated. Then chargeless particle, that is uncharged particle. So the particle shouldn't have a charge, that is chargeless or uncharged. So all are same, that is neutron is commenter. So we can't accelerate, that is chargeless particle, using cyclotron. Okay students, thank you.